Okay, well here's to hoping that this works. So remember, we're section 5.1, finding the derivative of natural log functions. So if you remember, if you could get it from the video the other day, the derivative of natural logs is just the derivative of what's inside. So in this case, it'd be 1 over what's inside, so 1 over x. Okay, so we're going to use those log function rules that you were supposed to watch from Khan Academy and use all those rules now together with everything else. So let's go over an easier example, hopefully. First example, let's find the derivative of the natural log of the square root of x plus 1. Okay, so first thing I'm going to do is same as what we've done with a lot of derivatives, is just do a rewrite. So the natural log of x plus 1 to the 1/2. Sorry for the lag. So again, a rewrite, and the rule is if you have an exponent in a natural log or in any kind of a log, you can bring the exponent down. So you get 1/2 log, or not, sorry, not log, natural log of x plus 1. Okay, so to find the derivative, f prime, the 1/2 as a constant, it stays in the front. The derivative of the natural log of x plus 1, take the derivative of what's inside, so the derivative of x plus 1, the derivative of x is just 1, and the derivative of 1 is nothing, so I'm just going to leave that 1 up there, all over everything that's on the inside, so it's x plus 1. So now when I multiply these together, I get 1 over 2 times x plus 1. And that's it. So we're just going to use the expanding and condensing rules in order to find derivatives now. All right, example 2. A little bit bigger one here, but hopefully you'll follow along. So the natural log, the derivative of the natural log of x times x squared plus 1, all of that squared, all over the square root of 2x cubed minus 1. Okay, and again, sorry, there should be a natural log here. We had to remember our natural log rules and all of our expanding and condensing. So this whole problem is a division problem, so when I rewrite this, not finding the derivative right now, but we're simply just rewriting it in nice ways, is the natural log of everything on the top minus the natural log of everything on the bottom. And I'm going to rewrite this at the same time. The square root is just the same thing as saying to the 1/2 power. Okay. Another rewrite over here on the left hand side, right here, I have a multiplication, so I can rewrite that again, do the natural log of x plus the natural log of x squared plus 1 squared minus, on this side I have an exponent, I'm going to bring the exponent in the front, the natural log of 2x cubed minus 1. Okay. Another expansion here. So the first one, there's nothing I can do with that. But this part right here, because of this square, I can bring that out front. So it's 2 times the natural log of x squared plus 1 minus 1/2 natural log of 2x cubed minus 1. Okay, so that's as far as I can break it down using just the expanding and condensing rules. So what I would do now is find the derivative of each individual piece. So the derivative of the natural log of x, the derivative of x is just 1 over x plus 2 times the derivative of the natural log of x squared plus 1. Remember, take the derivative of the stuff inside the parentheses, so the derivative of x squared plus 1 is simply bring the 2 down, so it's 2x over all that stuff, so x squared plus 1 on the bottom, minus 1/2 times So again, the derivative of all this stuff on the inside. Okay, actually, let me undo that. Let me highlight it. So I'm going to take the derivative of all the highlighted stuff, and the derivative of that is 6x squared. And then on the bottom, you just put all the highlighted stuff on the bottom. So 2x cubed minus 1. So now it's just simplifying some things. 1 over x, there's nothing to do with it. 2 times 2x, because remember this is like a fraction, so 2 times 2 is 4x. The bottom is still just x squared plus 1 minus. Here I'm going to do 6 over 2 is going to reduce to 3 over 1. So it's just going to be 3x squared over 2x cubed minus 1. And that's it. There's nothing else I'm going to put. I'm not going to put those together in any other fashion. I'm just going to leave them just like that. All right. So I don't know if you guys remember this or not from Flora's class last year or from any kind of pre-calc class or even Algebra 2, but natural log functions. So natural log functions are undefined when there is a negative number. So often what people do, or what any mathematicians do, is they all make sure that we know that we're actually just using, so we often use the natural log of the absolute value of whatever is inside. Okay, so this just, what that does is that it counteracts that negative part in there, so we know that it always has to be positive and it'll work out. So what happens is a lot of times you see a problem with a natural log of an absolute value and you're like, what do I do? And you simply just kind of forget the absolute values. So treat it as if there was no absolute value. Okay, so let's look at an example of what this would look like. Example 3 here. I want to take the derivative of the natural log of the absolute value of cosine of x. But again, remember, you're just going to treat it as if it wasn't a natural log, or it wasn't an absolute value. So do the derivative of what's on top, or the derivative of what's inside. If you remember, the derivative of cosine of x is negative sine of x over whatever's on the inside, which is just cosine of x. Okay, and then sine of x over cosine of x is simply just tangent of x. And I'm going to bring that negative over from the front right here. I'm going to bring that over. So then that's all there is to it. So when there's an absolute value bar, don't worry about it. Treat it the same. Do the same thing. Don't do anything new. And be done with it. All right. For your homework, what I would like you to do is page 325, numbers 48 through 52, and 61 and 62. All right. Thanks, guys.